Welcome back to Boring Science for Sleep, where the most fascinating discoveries in our universe become gentle companions for your journey into rest. Tonight, I invite you to settle into your most comfortable position, perhaps adjusting your pillow just so, letting your shoulders drop and release any tension from the day as your breathing naturally begins to slow and deepen. Feel the weight of your body sinking into the soft embrace of your bed, each muscle fiber relaxing as you prepare for this peaceful exploration of cosmic mysteries. Before we begin our gentle journey through the realms of light and speed, I'm curious about something that I'd love you to share in the comments below. If you could ride alongside a beam of light as it travels through the infinite darkness of space, what do you think you would see and feel during that impossible journey? Would the stars appear frozen in time like crystalline sculptures in an eternal gallery? Or would the universe transform into something entirely unrecognizable? Perhaps a realm where familiar concepts of motion and time dissolve into pure energy and possibility. Tonight, we're going to drift together through the ethereal realm of cosmic velocities, where the very fabric of space and time bends and flows in ways that challenge everything our everyday experience tells us about movement and speed. We'll discover whether there might be phenomena hidden in our universe that somehow transcend the legendary speed of light, that cosmic speed limit that has captivated scientists, philosophers, and dreamers for over a century, inspiring countless hours of contemplation and wonder. Imagine yourself floating weightlessly in the perfect darkness of deep space, far from any star or planet, surrounded only by the gentle glow of distant galaxies, scattered like luminous seeds across the infinite black canvas of the cosmos. Here, in this place of absolute stillness and tranquility, removed from Earth's atmosphere and the familiar pull of gravity, we can contemplate motion in its purest, most fundamental form. The universe is vast beyond comprehension and infinitely patient, and tonight we have all the time in the world to explore its most profound secrets about the nature of speed, motion, and the invisible threads that connect every corner of existence. Picture, if you will, a warm summer evening in 1905 when the air hangs still and peaceful over the ancient city of Bern, Switzerland. The scent of flowering lindens drifts through tall, narrow windows that have stood open since the afternoon, mixing with the faint aroma of freshly brewed coffee and the gentle fragrance of pipe tobacco that lingers in the modest apartment of a young patent clerk. The cobblestone streets below have grown quiet as the city settles into evening's gentle rhythm, the last echoes of horse-drawn carriages fading into the peaceful silence that descends like a soft blanket over the medieval cityscape. Gas lamps begin to flicker to life one by one along the winding medieval streets, their warm golden flames casting dancing pools of light that shimmer and reflect on the wet stones from an earlier evening shower. The ancient cathedral towers, weathered by centuries of Swiss seasons, release their bronze voices into the twilight air as the church bells toll the hour, their resonant chimes carrying across the red-tiled rooftops and flowing into the open windows of apartments where families gather around wooden tables for their evening meals. In this tranquil sanctuary, removed from the methodical precision of the day's patent office work, Albert Einstein sits at his simple wooden desk. A piece of furniture worn smooth by years of devoted use, its surface bearing the gentle scars, ink stains, and coffee rings that mark countless hours of mathematical contemplation and theoretical breakthrough. His pen moves slowly and deliberately across sheets of paper, illuminated by the warm, steady glow of an oil lamp, the flame dancing gently in the evening breeze that stirs the lace curtains and brings with it the distant sounds of the sleeping city. His mind is consumed by something that appears deceptively simple, yet proves profoundly mysterious: the fundamental nature of light itself and its strange, unchanging relationship to space and time. Einstein's dark eyes, reflecting the lamplight as he pauses in thought, contemplate questions that have puzzled humanity's greatest minds for generations. Questions about the very fabric of reality that will soon revolutionize our understanding of existence itself. For over 2 centuries, scientists across Europe and beyond had been measuring light speed with increasing precision and ingenuity, driven by an insatiable curiosity to understand this most fundamental of natural phenomena. Galileo himself, the father of modern physics, had attempted to measure light's velocity by stationing assistants with lanterns on distant hilltops, though his primitive methods could only conclude that light travelled extremely fast, faster than any earthly phenomenon he could observe or measure. Later, the brilliant Danish astronomer Ole Rømer made the first quantitative measurement of light's speed, by carefully timing the eclipses of Jupiter's moons, realizing with remarkable insight that the apparent delays in these celestial events were actually caused by the finite time required for light to cross the vast distances of the solar system as Earth moved closer to and farther from the giant planet in its orbital dance around the Sun. In more recent decades, scientists like Hippolyte Fizeau and Léon Foucault had employed increasingly sophisticated terrestrial methods involving rotating mirrors, spinning cogwheels with precisely machined teeth, and carefully calibrated optical apparatus that could measure distances and times with unprecedented accuracy. Each measurement, regardless of the experimental technique employed or the location where it was performed, converged on the same remarkable number, approximately 299,792,458 meters per second in the vacuum of space, a velocity so enormous that light could circle Earth's equator more than 7 times in a single second, racing across distances that would take sound hours to traverse. This velocity seemed absolute and unchanging, like a fundamental constant carved into the very architecture of the universe by some cosmic architect working with mathematical precision. No, but what troubled Einstein during these quiet evening hours, keeping him awake long after the city had settled into sleep, was a deeper, more philosophical question that cut to the heart of physical reality. What if this speed wasn't merely a curious property of light particles, but something far more fundamental to the structure of space, time, and causality itself? As you rest here in this peaceful moment, your breathing growing slower and more rhythmic with each gentle inhalation and exhalation. Imagine Einstein's revolutionary insight beginning to unfold like ripples spreading outward across the mirror-still surface of a mountain lake at dawn. This wasn't simply another measurement to be catalogued or another addition to the growing library of natural phenomena. It was pointing toward a complete revelation about the very nature of space, time, causality, and existence itself. Einstein realized, with the profound clarity that comes only through deep contemplation and rigorous mathematical analysis, that light speed represented something much grander and more fundamental than anyone had previously imagined. It was actually the speed of causality itself, the maximum velocity at which any influence, any information, any cause and effect relationship could propagate through the interconnected fabric of spacetime that underlies all of reality. In the gentle darkness of space that surrounds our pale blue dot, this cosmic speed limit creates a kind of universal democracy where all massless particles, regardless of their origin, destination, or purpose, travel at exactly the same magnificent velocity. Every photon of starlight that has ever reached Earth, from the most distant galaxies visible to our most powerful telescopes, to the warm, life-giving radiation from our own sun, has traveled at this same fundamental speed, weaving together an intricate tapestry of cosmic communication that spans the entire observable universe. Consider the light from our own sun, that familiar yellow star that has warmed and illuminated our planet for billions of years, supporting the emergence of life and consciousness on this small world. Each photon of sunlight takes precisely 8 minutes and 20 seconds to travel the 93 million miles that separate us from our nearest star, crossing the cold vacuum of space at light's relentless, unwavering pace. This means that when you step outside on a bright morning and feel the gentle warmth of sunlight on your face, you're actually experiencing the sun as it existed more than 8 minutes ago. A sun that has continued to burn, to rotate on its axis, to emit solar flares and coronal mass ejections while its light traveled across the solar system to reach you in this present moment. As we drift deeper into this peaceful exploration, settling more comfortably into the gentle flow of cosmic understanding, let's carefully and methodically examine what Einstein's special theory of relativity reveals about speed, motion, and the surprising flexibility of space and time themselves. The mathematics underlying these profound concepts are elegant in their simplicity, like a perfectly balanced musical composition that describes fundamental relationships between quantities we had always assumed were separate, independent, and unchanging throughout the universe. To truly understand how revolutionary Einstein's insights were and why they seem so counterintuitive to the scientific minds of his era, imagine two close friends meeting at a bustling train station on a crisp autumn afternoon. The station is alive with the sounds of steam engines releasing their pressure in great white clouds, conductors' whistles piercing the air with sharp, authoritative notes, and the gentle murmur of travellers saying their farewells and exchanging promises to write. One friend remains standing on the busy platform, hands tucked deep into coat pockets against the autumn chill, watching the steady flow of passengers and porters moving about their daily business with practiced efficiency. The other friend settles comfortably aboard a luxurious passenger train that begins to glide smoothly along polished steel tracks at a steady, unwavering speed of 60 miles per hour. The train car is elegantly appointed, with plush velvet seats in deep burgundy, polished brass fixtures that gleam in the afternoon light, and large windows framed with heavy curtains that offer panoramic views of the passing countryside like a series of moving paintings capturing the essence of the landscape. To the friends seated aboard the train, their delicate china coffee cup sits perfectly still on the small mahogany table beside their seat, as motionless and stable as if the entire train were permanently parked in the station's waiting area. The rich leather of the seat cushions remains unmoved, the brass reading lamp stands straight and steady without the slightest tremor, and a fountain pen rests motionless on an open notebook, its gold nib catching occasional glints of sunlight. From this passenger's perspective, everything within the train car exists in a state of perfect rest and tranquility. The landscape outside the large windows flows past in a gentle, dreamlike blur of golden fields dotted with red barns, ancient oak trees and distant mountains painted in shades of blue and purple by the afternoon haze. But inside the comfortable compartment, the laws of physics seem to operate exactly as they would if the train were completely stationary. A dropped coin would fall straight down to the carpeted floor in a perfect vertical line, not backward toward the rear of the car. Tea poured from an elegant silver pot would flow directly downward into the cup below, following the same graceful parabolic arc it would trace in a stationary tea room. But to the friend standing on the platform, watching the elegant train disappear into the distance with a long, mournful whistle that echoes off the station's brick walls, that same china coffee cup is clearly and unmistakably moving at exactly 60 miles per hour in the direction of the train's travel. Same cup, same moment in time, same physical object existing in the same universe, yet two completely different and equally valid descriptions of its motion through space. This simple but profound example illustrates the essence of relative motion, the fundamental idea that speed and velocity depend entirely on your frame of reference, your particular vantage point in the vast theatre of the universe. There is no absolute standard of rest, no cosmic reference point floating somewhere in space that determines the true motion of any object. Motion is always relative to the observer, always dependent on perspective, always a matter of which coordinate system you choose to use for your measurements. For centuries before Einstein's revolutionary insights transformed our understanding of reality, physicists had quite naturally assumed that light would behave according to these same intuitive principles of relative motion. The logic seemed unassailable and consistent with all human experience. If you were running toward an oncoming beam of light, common sense suggested that you should measure that light approaching you at a faster combined speed than if you were standing perfectly still. The speeds should add together arithmetically, just as they do when two cars approach each other on a highway or when you throw a ball forward from a moving vehicle. Conversely, if you were somehow traveling in the same direction as a light beam, perhaps riding alongside it on some fantastical cosmic vehicle, you should logically measure that light moving more slowly relative to your position, or potentially not moving at all if you could somehow match its speed exactly. This seemed not only logical and intuitive, but entirely consistent with all human experience of motion from the everyday world of carriages, trains, and flying birds. But the universe, as Einstein was beginning to realize during those quiet evening hours in his modest Bern apartment, had far more subtle, beautiful, and mind-bending plans than human intuition could possibly imagine or predict. In the early years of the 20th century, scientists throughout Europe and America conducted increasingly precise and sophisticated experiments designed to measure how Earth's motion through space might affect the speed of light when measured in different directions. Since our planet orbits the Sun at approximately 30 kilometers per second, and our entire solar system moves through the galaxy at roughly 220 kilometers per second, and our galaxy itself moves through space relative to other galaxies, it seemed entirely reasonable to expect that these various motions would create detectable differences in light's apparent speed, depending on the direction of measurement. The most famous and influential of these experiments was conducted by Albert Michelson and Edward Morley in 1887. Using an ingenious device called an interferometer that could detect incredibly minute differences in the time light takes to travel along perpendicular paths. This remarkable instrument split a single beam of light into two perpendicular rays using a carefully positioned half-silvered mirror, sent them along paths of precisely equal length, and then recombined them to create an interference pattern of light and dark fringes that would shift detectably if there were any difference in the light's travel time along the two paths. The experimenters confidently expected to find that light travels slightly faster when moving in the same direction as Earth's orbital motion around the Sun, and correspondingly slower when moving against it. This would create a measurable ether wind as our planet moved through the hypothetical luminiferous ether that most scientists believed filled all of space and served as the medium through which light waves propagated, much as ocean waves propagate through water or sound waves propagate through air. Instead, to their complete amazement and growing bewilderment, they discovered something that seemed utterly impossible, according to all existing physical theories. No matter how they oriented their sensitive equipment, no matter what time of day or season they performed their careful measurements, no matter how fast Earth happened to be moving through space at any given moment, light always appeared to travel at exactly the same speed in all directions. The constancy of light's speed was absolute, unwavering, and completely independent of the motion of both the source and the observer, a result so unexpected that it took decades for the scientific community to fully accept its implications. In the gentle progression of scientific understanding that has unfolded over the past century, researchers have discovered layer upon layer of evidence that this cosmic speed limit extends far beyond simple particles of light, governing the behavior of all the fundamental forces and interactions that hold our universe together in its intricate cosmic dance. The speed of light in vacuum, often denoted by the letter c in physics equations, appears to be woven into the very structure of physical law itself, forming the foundation upon which all other natural phenomena rest. This universal speed limit applies not only to photons, the massless particles of electromagnetic radiation that we perceive as visible light, but also to all other massless particles that exist in nature's grand symphony. The hypothetical gravitons that may carry the gravitational force across the vast emptiness of space, if they exist as quantum theory suggests, must travel at exactly this same speed. The gluons that bind quarks together within protons and neutrons using what physicists poetically call the strong nuclear force also propagate at light speed when moving freely through the vacuum of space, carrying their binding influence across the tiny distances within atomic nuclei. But here's where our gentle exploration becomes particularly intriguing and begins to reveal the true subtlety and sophistication of nature's design. While it remains absolutely true that nothing with mass can ever accelerate to reach the speed of light, as doing so would require infinite energy according to Einstein's equations, the universe has discovered remarkable and ingenious ways to work within and around these fundamental constraints, creating phenomena that can appear to exceed light speed without actually violating the underlying principles of relativity. Consider the expansion of space itself, a phenomenon that operates according to entirely different rules than the motion of objects through space. Picture in your mind a vast balloon being slowly inflated by some invisible cosmic breath. Small dots drawn on the balloon's surface gradually move apart from each other, not because they're actively traveling across the balloon's rubber surface under their own power, but because the surface itself is expanding and stretching, creating more space between them with each passing moment as the balloon grows larger. Yeah, in much the same way, distant galaxies throughout our universe can appear to recede from us at velocities that exceed the speed of light, not because these massive collections of billions of stars are actually moving through space at such tremendous speeds, but because the space between us and them is continuously expanding, driven by the mysterious dark energy that comprises roughly 68% of all the matter and energy in the cosmos, yet remains one of the deepest unsolved mysteries in modern physics. This expansion, which began during the Big Bang some 13.8 billion years ago and continues to accelerate today, allows certain regions of space to recede from our location at velocities significantly greater than the speed of light. The most distant observable galaxies, perched at the very edge of our cosmic horizon, like lighthouses on a vast and darkening sea, are moving away from us at more than twice the speed of light due to cosmic expansion. Yet this phenomenon doesn't violate Einstein's theory of relativity, because no information, no causal influence, no physical object is actually traveling faster than light through space. Instead, space itself is simply growing larger, like the balloon in our analogy, carrying matter along with it as it expands. Another fascinating realm where the concepts of speed and information transmission become beautifully complex involves the quantum mechanical phenomenon known as entanglement, what Einstein himself famously referred to as spooky action at a distance, because it troubled him so deeply with its apparent violation of locality and the principle that nothing can influence distant events faster than light can travel between them. When two particles become quantum mechanically entangled through their interaction, perhaps when a single photon is split into two correlated particles, or when two electrons interact and then separate, measuring certain properties of one particle instantly affects the corresponding properties of the other particle, regardless of how much distance separates them. This correlation occurs instantaneously. Apparently faster than light could possibly travel between the particles, even if they have been separated by millions or billions of miles across the cosmos. Modern experiments using increasingly sophisticated technology have confirmed beyond any reasonable doubt that entangled particles do indeed influence each other's properties instantaneously across vast distances. Scientists have successfully demonstrated entanglement between particles separated by hundreds of kilometers using satellite links, and the effects appear to be truly instantaneous rather than simply very fast. The correlations are so perfect and immediate that they seem to transcend the normal limitations of space and time. However, and this is crucial to understanding why entanglement doesn't actually violate relativity, this quantum connection cannot be used to transmit any actual information faster than the speed of light. The correlations between entangled particles are completely real and measurable, but they are fundamentally random from the perspective of each individual observer. When you measure an entangled particle and find it spinning clockwise, you instantly know that its distant partner must be spinning counterclockwise, but you cannot control which result you will obtain from your measurement. No message, no data, no controllable signal can actually travel between the particles. Only pre-existing quantum correlations are revealed when measurements are performed. Scientists working in specialized laboratories around the world have also observed phenomena in certain exotic materials where the phase velocity of light, the speed at which the peaks and valleys of light waves appear to move, can actually exceed the speed of light in vacuum. In some carefully engineered metamaterials with unusual optical properties that don't exist in nature, light pulses can even appear to exit a material before they have fully entered it, creating what seems like a violation of causality itself, where effects appear to precede their causes. But once again, detailed mathematical analysis reveals that no information or energy actually travels faster than the fundamental cosmic speed limit. These exotic effects involve the reshaping, redefinition, and restructuring of the light pulse itself as it interacts with the material's unique electromagnetic properties, not the transmission of information at superluminal speeds. The fastest parts of the pulse that carry actual information still propagate at or below the speed of light in vacuum, maintaining the universe's logical consistency.
As we continue our peaceful journey through theoretical possibility, let's explore one of physics' most intriguing speculative concepts: tachyons. These hypothetical particles exist purely in mathematical speculation, offering a fascinating window into physical laws' flexibility.
The word tachyon comes from Greek tachys, meaning swift. These theoretical entities would be born already traveling faster than light, not accelerated to superluminal speeds, but existing naturally where faster-than-light motion is their ground state. For tachyons, light speed would represent an impermeable barrier they could never cross from above, just as massive particles can never cross from below. They'd inhabit a mirror universe of motion where energy and speed relate oppositely to our experience. In our world, adding energy makes objects faster, removing energy slows them. But for tachyons, adding energy would slow them toward light speed, while removing energy would accelerate them to higher velocities. The fastest tachyons would have zero energy, racing at infinite speed, while the slowest would carry the most energy, barely exceeding light speed. This creates mind-bending possibilities. If tachyons could interact with ordinary matter, considered highly unlikely, they would experience time flowing backward relative to our normal experience. A tachyon, traveling from point A to B, would arrive before departing, creating closed time-like curves and potentially allowing information transmission into the past. Such time-reversed causality would enable tachyonic anti-telephones, devices sending messages backward through time. This could create all the paradoxes science fiction explores, warning your past self about future events, creating alternate timelines, or generating logical contradictions where effects precede causes. Fortunately for cosmic order, no experiment has detected tachyons despite decades of searching. Most theoretical frameworks suggest they probably don't exist, and the universe has built-in mechanisms preventing their creation or detection. Even if possible, tachyons would likely be unable to interact meaningfully with ordinary matter, existing in a separate reality realm, forever undetectable and irrelevant to observable physical processes. Yet tachyon mathematics serves an important purpose, reminding us that current theories may not represent reality's final word. There could be aspects operating according to undiscovered principles, phenomena transcending our understanding of space, time, and causality. In this moment's profound stillness, as your breathing finds its natural rhythm, let's contemplate spacetime's deeper nature, that mysterious four-dimensional fabric Einstein revealed as the true stage for all cosmic events. This isn't empty space punctuated by matter, but a dynamic, flexible medium that can be bent, twisted, and rippled by mass and energy. Einstein's general relativity revealed that gravity is actually space-time curvature itself. Imagine space-time as an infinite ocean, normally flat and calm. Massive objects create gentle depressions like bowling balls on a stretched rubber sheet, causing fabric to curve around them. Smaller objects naturally follow these curves, like marbles rolling along depressions. A planet orbiting a star travels the straightest possible line through curved space-time created by the star's mass. This cosmic fabric also supports gravitational waves, ripples traveling at light speed, carrying information about their sources across vast distances. When two black holes spiral together in a cosmic dance spanning millions of years, they create increasingly violent space-time distortions, eventually producing gravitational waves of extraordinary intensity. LIGO detectors have confirmed these waves, observing space-time stretching and squeezing by amounts smaller than 1/10,000th of a proton's width. Yet even these dramatic waves travel exactly at light speed, demonstrating this cosmic limit applies not just to particles, but to space-time's structure itself. During cosmic inflation, the first fraction of a second after the Big Bang, space-time expanded exponentially, growing by enormous factors in less than 10 to the negative 32nd seconds. Regions once in contact became separated by distances so vast that light hasn't had time to travel between them in 13.8 billion years since. This expansion explains the cosmic microwave background's remarkable uniformity. Without inflation, regions now separated by billions of light years would never have been in thermal contact, and we'd expect large temperature variations. But because distant regions were once close together before expansion separated them, they reached thermal equilibrium, creating the uniformity we observe today. As we drift deeper into tranquil contemplation, let's explore the quantum world where speed becomes beautifully complex and phenomena challenge our assumptions about motion, locality, and information flow through space and time. In the microscopic realm, reality operates according to principles seeming magical compared to everyday experience. Particles exist in multiple states simultaneously, tunnel through insurmountable barriers, and remain connected across vast distances through quantum entanglement. Consider virtual particles, brief quantum field fluctuations popping into existence and disappearing faster than light could travel between them. These ephemeral entities don't violate relativity because they cannot be observed or used to transmit information. They exist in quantum foam, the seething background underlying reality, contributing to forces while remaining beyond direct detection. The quantum vacuum, which we might think of as empty space, actually teems with activity at the smallest scales. Particle-antiparticle pairs continuously appear and annihilate in timeframes so brief they exist on borrowed energy, permitted by Heisenberg's uncertainty principle. Quantum tunneling presents another fascinating puzzle. Particles sometimes pass through energy barriers that should be insurmountable, appearing instantaneously on the other side without traveling through intervening space conventionally. The tunneling time can be vanishingly small, leading to apparent superluminal velocities, yet careful analysis shows no information travels faster than light during tunneling. The quantum wave function describing the particle's probability can extend across barriers instantaneously, but extracting information about the particle's state requires interactions propagating at light speed or slower. In quantum field theory, reality consists of fields permeating all space and time. Particles are localized excitations in these fields, like waves on an infinite ocean's surface. Light speed emerges not as any particular particle's speed, but as the fundamental rate at which disturbances propagate through quantum fields themselves. These fields exist everywhere simultaneously, but changes in field configurations can only propagate at light speed. It's like having a perfectly rigid rod stretching across the cosmos. The rod extends everywhere instantaneously, but pushing one end creates a compression wave traveling at sound speed within the rod's material. Throughout physics' gentle history, researchers have occasionally encountered phenomena appearing to challenge light's fundamental speed limit, leading to deeper understanding of nature's subtle ways of preserving cosmic order while allowing remarkable behaviors. In the 1970s, astronomers studying distant galaxies noticed something extraordinary. Certain galaxies with active supermassive black holes ejected material jets appearing to move across the sky faster than light itself. High-resolution radio telescopes revealed bright material knots moving at apparent speeds up to 10 times light speed. The resolution came through careful observation geometry analysis. These jets actually travel toward us at velocities close to, but less than, light speed, typically 95 to 99% of light speed. However, because they're angled slightly to one side as they approach, they create a powerful optical illusion, making their sideways motion appear greatly accelerated. Picture energetic particles racing toward Earth at 99% light speed, angled about 10 degrees from our direct line of sight. The particles travel so fast they nearly keep pace with their emitted light. Light from distant particle positions has only a small head start over light from closer positions. When both signals reach our telescopes, the time difference is much smaller than the actual travel time between positions, creating faster-than-light motion illusions while actual velocities remain below the cosmic limit. Researchers have also created laboratory conditions where light pulses appear to travel faster than vacuum light speed, sometimes appearing to exit materials before fully entering them. Scientists have produced negative group velocity, where light pulse peaks appear to travel backward, exiting experimental apparatus before the pulse completely enters. However, while the group velocity, the pulse peak's apparent speed, can exceed light speed or become negative, the wavefront carrying the first signal indication still propagates at or below vacuum light speed. No usable information can be transmitted faster than the fundamental limit, even though pulse peaks might appear to move faster. In intergalactic space's vast quietude, where galaxies float like luminous islands separated by millions of light-years of near-perfect vacuum, exists something even more mysterious than light speed itself, a force so subtle yet overwhelmingly powerful that it drives the entire universe's accelerating expansion. We call this enigmatic influence dark energy, comprising roughly 68% of all existence's matter and energy, yet detectable only through its large-scale gravitational effects on space expansion. Unlike ordinary matter creating attractive gravitational forces, dark energy exerts anti-gravitational influence, pushing space apart, causing accelerating universal expansion. Dark energy operates through space expansion itself, allowing distant universe regions to separate faster than light without violating relativity. This doesn't involve galaxy motion through space. Rather, it represents continuous new space creation between existing galaxies, like cosmic balloon inflation, carrying all matter along as it grows. Edwin Hubble's 1920s observations first revealed distant galaxies moving away with velocities proportional to distance, Hubble's law. The most distant observable galaxies recede at more than twice light speed due to space expansion between us and them. This creates natural horizons around every universe observer, boundaries beyond which information can never be received, regardless of waiting time or instrument sensitivity. Light from regions beyond the cosmic event horizon fights a losing battle against expansion, forever unable to bridge the growing space gap. Our observable universe spans approximately 46 billion light-years in radius, despite being only 13.8 billion years old. This apparent contradiction resolves remembering space has expanded throughout the entire time distant galaxy light traveled toward us. Galaxies were much closer when their light began the journey, but expansion carried them to current tremendous distances. The accelerating expansion has profound implications for the universe's far future. If current trends continue, galaxies beyond our local group will eventually be carried so far that their light can no longer reach us. Future civilizations might see a cosmos containing only the few dozen gravitationally bound local galaxies, with no evidence of a larger universe beyond. In contemplating cosmic velocities and fundamental limits governing universal motion, it's natural to consider our own thoughts and consciousness. How quickly do neural signals travel through our brains? How does thought speed compare to the cosmic speed limit governing electromagnetic radiation? Electrical impulses carrying information between brain neurons travel at speeds ranging from about 1 meter per second for small fibers to roughly 120 meters per second for large insulated pathways. These velocities are extraordinarily slow compared to light speed, millions of times slower than electromagnetic radiation propagating through vacuum. A neural signal from toe to brain requires several milliseconds, explaining the tiny delay between stubbing your toe and experiencing pain. Even the fastest neural processes underlying conscious thought operate at speeds seeming glacially slow compared to quantum mechanics or electromagnetic phenomena. Yet in this apparent slowness exists profound beauty and remarkable computational efficiency. Neural activity's leisurely pace allows for complex integration, processing, and reflection characterizing conscious experience. If our brains operated at light speed, the delicate neural network dance giving rise to thought, memory, emotion, and awareness might be impossible. The human brain contains approximately 86 billion neurons, each connected to thousands of others through an estimated 100 trillion synaptic connections. This creates staggering network complexity processing information through massively parallel computation, with millions of pathways operating simultaneously to generate consciousness's rich, unified experience. As you rest peacefully, your brain actively processes the concepts we've explored, integrating new information about cosmic speeds with existing knowledge. Neural pathways form new connections, strengthen existing synapses, and create physical brain structure changes corresponding to learning and memory formation. This process continues even as you sleep, with different sleep stages serving important functions in memory consolidation, pattern recognition, and integrating new experiences with existing knowledge. The speed of thought, while slow compared to electromagnetic radiation, is perfectly matched to human experience timescales. In space's soft darkness, where galaxies drift like distant light cities across the vast cosmic landscape, exists profound poetry in how physical laws maintain elegant consistency across all existence scales. The same cosmic speed limit governing individual photon motion also determines gravitational wave propagation from colliding black holes and information flow through quantum fields. This universal speed limit creates cosmic democracy, where all massless particles travel at exactly the same velocity through space vacuum, regardless of their role in the force symphony. Whether carrying electromagnetic force illuminating our world, gravitational force orchestrating planetary dances, or strong nuclear force binding quarks within atomic nuclei, all move at the same fundamental speed connecting every observable universe corner. This speed's constancy creates causality's foundation, ensuring causes always precede effects, information flows orderly from past to future, and the universe maintains logical coherence across all space and timescales. Without this cosmic speed limit, reality might dissolve into chaos, with effects preceding causes and orderly physical processes breaking down completely. Yet within these constraints, nature has discovered countless ways to create phenomena seeming to transcend limitations while actually confirming underlying principles' deeper elegance. Quantum entanglement creates instantaneous correlations without transmitting information faster than light. Cosmic expansion allows space growth at any rate without violating object motion through space. Virtual particles appear and vanish without becoming real enough to carry messages. The universe appears constructed with almost mathematical elegance, where every apparent fundamental law exception actually demonstrates more sophisticated understanding of how those laws truly operate. Reality seems designed by a cosmic poet, delighting in creating beauty through constraint and freedom interplay, limitation and possibility. Consider the remarkable fact that physical constants, light speed, gravitational strength, electron charge, proton mass, appear to have exactly the values necessary, allowing stars, planets, atoms, molecules, and ultimately life existence. If any constants were slightly different, the universe might be a lifeless expanse, unable to support complex chemistry and thermodynamics, making organized matter and conscious observers possible. As our peaceful journey through the cosmos of speed and motion gently approaches its conclusion, let's take a moment to contemplate the vast, beckoning horizons of human knowledge that stretch before us like an infinite ocean of possibility and wonder. Despite more than a century of remarkable progress since Einstein's revolutionary insights first transformed our understanding of space, time, and gravity, enormous mysteries remain that challenge our current theoretical frameworks and push the boundaries of our experimental capabilities to their very limits. We still don't fully understand the true nature of dark energy, that mysterious and pervasive force that drives the accelerating expansion of the universe and comprises roughly 68% of all matter and energy in existence. Despite decades of observations using increasingly sophisticated space-based telescopes, ground-based observatories, and ingenious detection methods, dark energy remains almost completely enigmatic in its fundamental properties, origin, and ultimate destiny. We can measure its effects on cosmic expansion with extraordinary precision, mapping how it influences the motion of distant galaxies and the evolution of cosmic structure, but we cannot directly detect it, interact with it, or even begin to explain why it exists or where it comes from. Similarly, dark matter, the invisible substance that comprises about 27% of the universe and provides the gravitational scaffolding around which galaxies and galaxy clusters form their majestic structures, continues to elude direct detection despite decades of increasingly sophisticated experiments designed to capture or create these elusive particles. Underground laboratories buried deep within mountains to shield them from cosmic radiation, particle accelerators pushing the boundaries of achievable energies, and space-based detectors scanning the cosmos for the telltale signatures of dark matter. Interactions have all failed to provide definitive evidence of these mysterious particles that theory tells us must exist. We can observe dark matter's gravitational effects on visible matter and light with remarkable clarity and precision, mapping its distribution throughout the cosmos like invisible sculptors shaping the architecture of reality. We can watch how it influences the rotation of galaxies, the formation of cosmic structures, and the bending of light from distant sources. Yet the fundamental nature of this dark matter, whether it consists of exotic particles like tachyons or WIMPs, represents modifications to our understanding of gravitational laws, or points towards something else entirely beyond our current imagination, remains one of the greatest unsolved problems in modern physics. The intersection of quantum mechanics and general relativity represents another profound frontier where our current understanding reaches its fundamental limits and begins to break down completely. While both theories have been tested to extraordinary precision within their respective domains, quantum mechanics describing the bizarre behavior of atoms and subatomic particles, general relativity governing gravity, and the large-scale structure of spacetime, we still lack a complete theory of quantum gravity that can describe what happens when quantum mechanical effects become important in regions of extremely curved spacetime. Consider the mysterious interior of black holes, where matter is compressed to theoretical infinite density and space-time curvature becomes so extreme that our current equations break down completely, producing mathematical infinities that signal the failure of our theoretical understanding. Or contemplate the first moments after the Big Bang, when the entire observable universe was compressed into a region smaller than a proton and quantum effects dominated gravitational physics on scales where both theories should apply simultaneously. Some theoretical approaches, such as string theory and loop quantum gravity, attempt to achieve this long-sought unification by proposing that space and time themselves might not be fundamental entities, but rather emergent properties of more basic constituents operating at scales far smaller than anything we can currently observe or measure. These theories suggest that our familiar 3 dimensions of space and 1 dimension of time might be embedded within a higher dimensional space where different rules apply and where phenomena might exist that transcend our current understanding of speed, causality, and information transmission. String theory, in particular, proposes that all fundamental particles are actually tiny vibrating strings or loops existing in a space with as many as 11 dimensions. Most of these extra dimensions will be compactified or curled up so tightly that they remain invisible at the scales we can currently probe, but they might still influence the physics we observe in subtle ways that could eventually be detected through precision experiments or astronomical observations of unprecedented sensitivity. The relationship between consciousness and physical reality remains one of the deepest mysteries in all of science, touching on fundamental questions about the relationship between subjective experience and objective physical processes that unfold according to the laws of physics. How does the complex but apparently mechanical activity of neural networks somehow give rise to the rich inner world of conscious awareness, complete with subjective experiences, emotions, dreams, and the sense of being a unified self embedded within the physical universe? In the gentle silence that surrounds us now, as your breathing has found its natural rhythm of peaceful relaxation, and your mind has wandered through vast cosmic landscapes of space, time, and infinite possibility, there's something profoundly comforting and deeply reassuring about the consistency and reliability of the physical laws that govern our universe. The speed of light stands as a kind of universal constant, a dependable foundation that underlies all the beauty, complexity, and wonder of existence itself, remaining faithful and unchanging across billions of years of cosmic evolution. Tonight, as you've journeyed through concepts that span from the quantum mechanical realm of virtual particles and zero-point energy to the cosmic scales of galactic expansion and dark energy, you've touched something eternal and universal that connects every aspect of reality across all scales of space and time. The same fundamental principles that govern the delicate dance of electrons around atomic nuclei also guide the stately rotation of spiral galaxies across billions of light-years of space. The same speed limits that constrain the propagation of electromagnetic radiation also ensure that causality flows in an orderly, logical fashion from past to future throughout the entire observable cosmos. There's a profound harmony in this consistency, a cosmic symphony where every note, from the rapid vibrations of quantum fields at the smallest conceivable scales to the slow, majestic expansion of space itself at the largest scales, plays its essential part in maintaining the ordered beauty and logical coherence of reality. The universe doesn't need to hurry or rush toward any destination. Time flows at its own, measured, unhurried pace. Space expands according to its own ancient schedule, and the fundamental forces operate with a patience and persistence that spans billions of years. This cosmic patience is perhaps the most beautiful and reassuring aspect of universal order. Stars take millions of years to form from collapsing clouds of gas and dust, carefully fusing hydrogen into heavier elements in their nuclear furnaces, while slowly evolving through their stellar life cycles. Galaxies develop over billions of years, slowly converting primordial gas into successive generations of stars that enrich the cosmic environment with the chemical elements necessary for planets, life, and consciousness. The universe itself unfolds its grand story across timescales so vast that the entire history of human civilization appears as but a brief, brilliant flash in the cosmic timeline. Yet within this immensity of space and time, there's room for consciousness to emerge, for awareness to contemplate its own existence, and for minds like yours to ponder the very foundations of reality itself. You are part of this cosmic story, intimately connected to every star through the elements forged in stellar nuclear furnaces billions of years ago, linked to every galaxy through the expanding fabric of space-time that carries us all on this remarkable journey through the universe. The atoms that compose your body, the carbon in your muscles that allows them to contract and move, the calcium in your bones that gives them strength, the iron in your blood that carries oxygen to every cell, the oxygen you breathe that sustains the chemical reactions of life, were once scattered across the cosmos, traveling at various speeds through the darkness of interstellar space before gradually coming together through the patient influence of gravity and electromagnetic forces to form the complex molecular structures that make up your existence. In a very real and literal sense, you are made of stardust, a collection of cosmic matter that has somehow organized itself into a pattern capable of consciousness, awareness, and wonder at the beauty and mystery of existence. The neural activity in your brain, operating at its measured pace millions of times slower than the speed of light, has enabled you to contemplate speeds and distances that dwarf human experience, to understand principles that govern the behavior of matter and energy across the entire observable universe. As you rest in this peaceful moment, surrounded by the invisible presence of electromagnetic fields, gravitational waves, and quantum fluctuations that permeate all of space, you can take comfort in knowing that you exist within a universe of profound order, beauty, and consistency. The same laws that guided the formation of the first galaxies also govern the gentle beating of your heart. The same forces that hold atoms together in stable configurations also maintain the delicate chemical processes that sustain your life and consciousness. As we bring our gentle exploration to its peaceful close, imagine yourself floating serenely in cosmic darkness, suspended in deep space's perfect silence, surrounded by distant stars' soft, eternal glow whose light has traveled for years or centuries to reach this quiet contemplation moment. Each light point represents a sun perhaps like our own, warming planets that might harbor their own forms of beauty and complexity. Whether there are speeds faster than light we simply cannot perceive remains one of the most beautiful mysteries awaiting future exploration. Perhaps in dimensions we cannot currently access, or through quantum mechanical channels operating according to undiscovered principles, there exist phenomena transcending our current understanding of speed and locality. But for now, in this peaceful reflection moment, there's something deeply satisfying about the cosmic speed limit governing our observable universe. It ensures reality's magnificent story unfolds orderly and logically, with causes preceding effects, information flowing coherently from past to future, and matter and energy's gentle dance continuing according to comprehensible and beautiful principles. This speed limit creates a cosmic horizon around us, a boundary defining the observable universe's edge and separating the knowable from unknowable. Light from regions beyond this cosmic event horizon will never reach us, no matter how long we wait. These distant realms exist in eternal silence, forever separated from our causal influence by space-time's fundamental constraints. Yet rather than feeling isolated by these cosmic horizons, we can find wonder in the vast interconnectedness that light speed makes possible. Every photon reaching your eyes connects you directly to its source, whether the sun that warmed Earth 8 minutes ago, a star that shone decades ago, or a distant galaxy that emitted light billions of years ago when the universe was young. Rest now knowing you exist within a universe of profound order, beauty, and consistency, where the same fundamental laws governing galaxy formation also govern your heart's gentle beating. The cosmos is patient and enduring, unfolding its wonders at its own magnificent pace, with no need for haste in revealing the infinite mysteries and beauties surrounding us all. Sweet dreams, fellow traveler through the cosmic dark. The universe will continue its patient expansion while you rest, carrying all of us together on this remarkable journey through space and time, guided by physical laws that are both constraining and liberating, creating a cosmic environment where beauty, complexity, consciousness, and understanding can emerge from matter and energy's dance across the vast stages of space and time.